go over a few more sort of examples of naming and how to proper name all these things. And just again, to make sure everybody's sort of on the right page. Obviously, if you do have a question, feel free to ask along the way. Okay, so really, as I mentioned before, sort of in organic chemistry, it's really, again, all about, you know, a few sort of steps that you follow when you do go sort of naming. And again, those steps really are 100% of the time always starting with the longest carbon chain. And as we've talked about and as we've seen, it's not necessarily always the straightest, that's the longest. Remember that, you can go straight, then maybe you go up, maybe you go over or something like that. The only difference is, or again, the only deal is when you are counting the longest carbon chain, you just can't go backwards. So again, you got to start in one direction and continue through until you kind of hit a dead end. You can't like back it up and go the other way. So you do want to usually, when you're doing nomenclature, you do want to really sort of check all of your options. So sometimes you're kind of surprised, like, oh whoa, I didn't even like kind of see that one there, in terms of the longest carbon chain. When you do so, again, really important, as we've been talking about, that it will pretty much or should match one of those first 10 alkane names. And that basically is going to be kind of like the base of your name, really. That's going to kind of go at the end. It's going to be really what you're going to build your name off of. Once you do that, sometimes it's good. Like I was highlighting it. Sometimes it's good to put a box around it. And then what you want to look at is, all the groups that are attached. So today we talked about some groups. Groups are, again, basically guys that, are in the compound, but they're not part of that continuous carbon chain. They're sort of attached in, and you want to identify all your groups. Remember, for the most part, a lot of those groups will be what are referred to as alkyl groups, which again are based off of those first 10 alkanes. So hopefully you can kind of see a pattern here, that those first 10 alkanes are super important in terms of organic chemistry. As we talked about there today, you basically drop the ANE part of the name and you put YL at the end. And again, we can get some different types of groups depending on the connectivity there, if it's connecting through, say, a primary carbon, secondary, or even a tertiary carbon. Once you do that, the next thing that you want to do is number the longest carbon chain. And the goal of numbering is to give, in this case of alkanes, is to give the groups the smallest number. So again, it's you want to go, in most cases, you have really the option of going left to right or right to left. And again, whichever way ends up giving the group sort of the smaller number is really what you want to go for. Once you sort of lock in everybody in terms of which way you're going to number, you can't go back and forth. So you say, hey, I'm going left to right. I got to go left to right in terms of my naming or my numbering. And every group will be numbered accordingly. And then really the last thing to do is to really put the groups in alphabetical order, regardless of really the number that's there. So again, if you have like a higher number, but it's alphabetically, it should come first. The higher number comes first, and the alphabetical guy comes with it. And also, regardless of prefix. So even if you have a prefix, you ignore the prefix and you put them in order, alphabetical order. And again, the last kind of housekeeping stuff, as we talked about, again, between a number and a letter, you should put a dash. And anytime you go with two numbers, you do need the comma between the two numbers. It is all about, as I mentioned before, it really is all about telling a person exactly where you could find everything. It's all really about, location, if you will, and really giving everybody an exact sort of location where you could find, everybody located. All right, so why don't we try a couple here and see? Let's see here. Let's go this way, I think. Let's go this. Let's go this. Let's go that, 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 and that, along with that. So take a second and give the name for that. And let me draw one more here. Let's just go with kind of a weird one, maybe. A lot of carbons going on. A little bit this way too. Why not here? Go that way and go that way. All right, why don't you take a few minutes here, and for both of these, come up with the name. Again, try to follow these steps and see if we all end up in the same spot. Okay, let's take a look and kind of see how you're doing. We'll start with just randomly drawing lines. We'll start with the one on the upper right there. All right, let's go that. So again, first rule, as we've been talking about, is we really want to find the longest continuous carbon chain. Sometimes it's best just to start straight. Obviously, if we go straight here, we got 1, 2, 3, 4, 5. Even though we're kind of done with the straight part, we really haven't hit a dead end because we can go down. So that's 1, 2, 3, 4, 5, 6, and 7. We kind of go all the way through here. I'm venturing to guess that that's probably the longest carbon chain. But again, we should probably also take a look at some of our other options just to make sure. And for example, if we started here and went this way, that would be 1, 2, 3, and 4, which is obviously less. If we started on the bottom here and went up, 1, 2, 3, 4, 5, and 6, which is also less than 7. So again, the one I highlighted there does appear to be the longest continuous carbon chain. Again, you could go up, you could go down. The only thing you cannot do is backtrack. And that's why when I got to the end here, I was all good. I could continue back down and it would all still be a continuous carbon chain, even though it's drawn like that. Any questions on that so far? That then gives me, I lost track. Was that 7? Was it 1, 2, 3, 4, 5, 6, 7? So again, 7 carbons takes us back to our first 10 alkanes. That tells us that the base of our name here is going to be heptane. We could then identify sort of what is not part of the chain, but a group. And in this case, it looks like this is our lone guy hanging out there. And that is, again, a 1 carbon group based off of methane. Because it's an alkyl group, we drop the last part of methane, and it now becomes a methyl group. Any questions on that there? We then want to move on to numbering our chain. We have basically 2 options. We could go kind of left to right. And if we did that, I'll go on the left here. 1, 2, 3, 4, 5, 6, 7. So going sort of in the blue direction, that would put our methyl group at carbon number 5. Now, if we went the opposite direction, so we'll go purple that way, starting over here as carbon 1, that would be 1, 2, 3, 4, 5, 6, and 7. That going the purple direction puts our methyl group at carbon number 3. And again, it is as simple as 3 is less than 5. That means that if we were to number this chain, we would want to go in this direction like we did here in the purple. Any questions on that there? All that's left is just to put it together. So the 3 tells us where the methyl group is located. So we go with a 3 and a dash methyl, again, dash between number and letter, and we finish it up with a heptane. So that would be 3-methyl heptane. Any questions on where any parts of that name came from? Okay. Then let us take a look over here then at our second option here. A little bit more stuff going on here. Again, even if it kind of looks perhaps a little bit more crazy, you still want to follow the same steps. So we will do that here. In this case, since there's maybe a little bit more options in terms of carbons, there might be a few more ways we need to check. So let us just start trying to check our different chains. So again, we could kind of just start straight across. So let's just go straight across here. That would get us 1, 2, 3, 4, 5, and 6. So that's 6 so far. We then could perhaps go, I'll change colors. We could go this way, 1, 2, 3, and go up 4, 5, 6. So that's 6 as well. So 6 so far. We also could then go 1, 2, 3, 4, 5, 6, 7. So that now beat the other 2 ways. That is 7 going that way, longer than our 6 going straight across, and longer than our 6 coming up this way. So we'll kind of get rid of some of those extras there. All right. We still have perhaps a couple other things to check in terms of directions, believe it or not. We could go this way, 1, 2, 3, 4, 5, 6, 7. That also is 7. So that seems good so far, but there is one more way we could go, I think. So if we went this way, 1, 2, 3, 4, 5, 6, and then go up 7 and 8. So actually we do get 8 if we zigzag kind of up that way, which beats our 7. And I think that at this point would be a winner there. So we're going to go that way. Any questions on that so far? Okay, so the main chain here is actually these 3, 4, 5, 6, 7, and an 8 in this case, right there. And 8 carbons would tell us that it is octane. And again, as you saw there, is why it's really, try that again, octane. There we go. That's why it's really important to make sure that you really do sort of check all your options. I've seen people do this one and stop at 6 going, seems like a pretty large number. It might be it. I've seen people stop at 7, and obviously there's one last way sort of hidden in there that does get us to 8. Once we have our main chain, we want to identify what groups there are. So obviously hanging off of here, we have a 1 carbon group, and hanging off of here, we have a 2 carbon group. 1 carbon group based off of methane, which then becomes a methyl group. 2 carbon group based off of ethane, ANE, gets dropped. Again, we put in the YL, and that is what is known as a ethyl group. Any questions on that so far? All right, now what we want to do is proceed to numbering. Again, we have a couple of options. We will go left to right here. This is going to be carbon 1, carbon 2, carbon 3, coming down, carbon 4, carbon 5, carbon 6, carbon 7, and carbon 8. So going left to right direction, we end up with a group at carbon number 4, which is our ethyl group. And we end up at carbon number 6, our methyl group. Our other option would be to start on the right there and come down in terms of our numbering. So we'll go with blue maybe. So going this way, 1, 2, 3, 4, 5, 6, 7, and 8. Going sort of the blue direction here, or right to left. We end up with the methyl group there at 3. And we end up with the ethyl group at 5. Any questions on that so far? 2 options. Again, in comparison, I believe 3 is less than 4. So 4 and 6 are higher numbers than 3 and 5. So in this case, we would want to go in the blue direction. So we don't need our other direction here. Get rid of that, rid of that. All right, so now we're actually ready to put these guys together, and we want to put it together here alphabetical. That means that E does come before M. So again, here our E would come before M. And even though the E has a bigger number, we will end up with 5 ethyl dash 3 methyl, and the base of our name there, octane. Any questions on that name there? Or either name? Okay. Then let us try maybe a couple more here just to make sure. So let's do this guy here. And let's see what else. Maybe let's do. Let's do one more here. Let's do this guy. All right, take a couple minutes again, come up with the IUPAC name for each of these here. Take a look, and again, following our same steps here. We'll start with the top one. We want to find that longest continuous carbon chain, so might as well just run straight across here. So that is 1, 2, 3, 4. If I could count, try that again. 1, 2, 3, 4, 5, 6. Other options would be go this way, 1, 2, 3, and then go up 4, 5. So that looks shorter. Another option would be to kind of go 1, 2, 3, 4, 5, and then up, which would be 6. So that's the same as straight. And I guess your last option there, or one of your last options, let's get rid of some of these here. You could go 1, 2, 3, 4, 5, and 6, which matches it. And you also could go 1, 2, 3, 4, 5, 6, which also matches it. So it looks like in multiple ways you could get to 6, and the true full answer is you could choose any of the ways, and they really, in most cases, will give you the same name. So, you know, you don't necessarily have to take the straightest, but they should end up with kind of the same name. I personally think if you kind of go with the straightest, it makes it a little bit easier to see everything else. So we'll go with the straight run here of 6 in a row, which gives us our base of our name as hexane. We obviously then have our 1 carbon group, which is a methyl group. We then have our 2 carbon group based off of ethane, which is a ethyl group. Any questions on that so far? Now we're down to numbering. So if we go left to right here, 1, 2, 3, 4, 5, and 6. So left to right, we end up with groups at 3 and 5. If we go right to left, 1, 2, 3, 4, 5, and 6, we end up with groups at 2 and 4, looks like. And that 2 and 4 is a smaller number than the 3 and the 5. So we would want to number this going, obviously, in the right to left direction. Any questions on that so far? Putting all this together here, that means because we chose right to left, our methyl will be the 2, our ethyl will be the 4. And again, alphabetically speaking here, ethyl before methyl, E before M, gives us a 4 ethyl, even though it's got a bigger number, dash 2 methyl. And then we tack on our hexane at the end. Any questions on that particular one there? Okay, then rolling through here, we'll go straight across again. 1, 2, 3, 4, 5, 6, 7. Other option would be to go straight. 1, 2, 3, 4, 5, go up 6 and 7. So that's the same. Other options look a little bit shorter. 1, 2, 3 down is 4. Obviously 1, 2, 3 is 3. We could go this way here. 1, 2, 3, 4, 5, 6, 7. Coming up that way, which is also 7. So it does look like 7. And again, I was talking this way. 1, 2, 3, 4, 5, 6, 7. Looks like we're at 7 no matter which way we go. So we will take the straightest 7 there, which is straight across. 7 carbons in a row then tells us that we are looking at heptane. If I get it right, heptane as the base of our name. We then see a 2 carbon group attached here, which is a ethyl group. We have a 1 carbon group based off of methane, which would be a methyl group. And we have a 1 carbon group right there, which is also a methyl group. We now have 2 of the same groups in this particular compound. That means that we do use a prefix, and this would not just be methyl, but it would be called here dimethyl, di because there are 2 methyl groups in the compound. Again, does not have to be on the same carbon, but actually just in the compound. Any questions on that so far? All right, we are down to numbering here. So off we go number wise. Let us go left to right. We got a 1, we got a 2, we got a 3, we got a 4, we got a 5, a 6, and a 7. So going left to right, we got some groups at carbon, looks like 2, 3, and 5. If we number the other way, 1, 2, 3, 4, 5, 6, and 7, looks like we end up with groups at 3, 5, and 6. Again, simple as 2 is less than 3, so we would not want to go this way. So in this case, we would want to number left to right here. Any questions on that? All right, so now we got to put everybody together correctly here. So obviously this methyl group, where are we at there? Come here. Yeah, no, I can't see where I'm writing. I'm just gonna start writing. There it is. All right. That is carbon 2. This is carbon 3, and then obviously our ethyl group here would be 5. All right, so because we're going to go alphabetical here, we basically got dimethyl and we got ethyl alphabetical here. It is still E before M. So in this case, when we have a prefix, we ignore the prefix and go with the first letter. So that E is alphabetically before the M, which means the proper name here would be, starting with the ethyl at carbon number 5, 5-ethyl dash. We need to give the number of both of those methyls. So that is 2 and 3. So that is a 2, 3, comma between two numbers, tells us that carbon number 2, there's a methyl group. Carbon number 3, there's a methyl group. And that is 2 methyl groups, which is known as dimethyl here. And lastly, heptane. Putting that together would be heptane. So 5-ethyl, 2,3-dimethyl heptane, we're basically just giving locations, and that's what all this really boils down to. We're basically telling people when we look at the name, I have 7 carbons, and on carbon number 5, you will find an ethyl group. At carbon number 2 and carbon number 3, you will find a methyl group. So again, the name is really just about telling people where everything's located. Same thing here. I have 6 carbons. At carbon number 4, you'll find an ethyl group. At carbon number 2, you'll find a methyl group. Any questions on going from formula there to name? Okay, now just as important, obviously, is if you're given a name and you need to draw it, you need to be able to do that as well. So let's talk a little bit about doing that. And I personally think that it's kind of the easier of the two. So I'm just going to make one up and hope it works. We'll go with 6-ethyl, do 3,3-dimethyl decane. I'm going to regret that in a second. Decane here. All right. All right, so you got this name. You may look at it and go, whoa, that looks like a very long name. I'm not really sure what to do with that. But actually, when you're given the name, it's actually really the sort of easiest of anything else. And that's because the name pretty much tells you what you should do. And the very first thing you should always do if you have a name and you want to draw a formula is you should always start backwards. So you should always start in this case with the name kind of right to left and work your way in this direction. So what I mean by that is simply we would start with the back part here, and decane means 10, which is why I regretted writing that. I think that is 10 carbons, and that's really what all you should start with is just lay up carbons, nothing else. Just lay up like 10 carbons, apparently. That is 4, that is 5, that is 6, that is 7, that is 8, that is 9, not 10, I hope. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Those 10 carbons represents decane, and good news is I just finished that part of the name. What is left is basically to put our groups on. And the good news is because you are drawing it, you can number it whichever way you like. You can number it left to right, which means if you went left to right, this would be carbon number 1. If you went right to left, this would go over here on the right-hand side would be carbon number 1, and you would obviously go in that direction. So I'm going to go left to right, which means over here on the left is carbon number 1. which means obviously this would be carbon number 2, carbon number 3, and so forth all the way across. And basically, I'm just going to kind of fill in what it says. So dimethyl means I have 2 methyl groups, and they both happen to be at carbon number 3. So that's what I would fill in next. A methyl group at carbon 3, another methyl group at carbon 3. That takes care of that name. What is left now is carbon number 6. There should be an ethyl group. And again, because I started on the left here as carbon number 1, next to it would be carbon number 2, carbon number 3. That means that is carbon number 4, that is carbon number 5, and that is carbon number 6, what we're looking for. Ethyl group is a 2-carbon group, and that is a CH2CH3. You could have, if you wanted to, drew it on the bottom. It does not matter. And that takes care of that. So we need to finish out our structure here. And this is where we come back to what we were talking about previously, that carbon wants 4 bonds. And everything else here at this point would be hydrogens to get carbon to 4 bonds. So let's just start on the left-hand side. This carbon has 1 line coming in, which means it has 1 bond. That means it needs 3 hydrogens to be complete. The carbon next to it has 2 lines coming in, which means to get it to 4, it needs 2 hydrogens. The carbon next to it, which is carbon number 3, has 1, 2, 3, 4 lines coming in, which means it has 4 bonds. It should have no hydrogens. The carbon next to it, which is carbon number 4, has 2 lines coming in, which means it needs 2 hydrogens. Carbon number 5 also has 2 lines, which means it needs 2 hydrogens. Carbon number 6 has 1 line, 2 lines, 3 lines, which means it needs 1 hydrogen to get the 4. Carbon number 7 has 2 lines, which means it needs 2 to get to 4. Carbon, I lost track there, 8, I think, has 2 lines, needs 2 hydrogens. Carbon number 9, also 2 lines, needs 2 hydrogens. And lastly, carbon number 10 has 1 line, needs 3 hydrogens. Any questions on that? So always work your way backwards and start with just the carbon backbone and kind of fill things in. So to finish up here for tonight, why don't we take a look at 2 and give you a try here. So why don't you do 2, 2, 4 trimethyl pentane. And why don't you draw the condensed formula for 2-bromyl 3-chloral butane. All right, so take a minute or 2 here, draw the condensed formula for each of these and see what you come up with. Again, work backwards this direction. Okay, let's take a look here since we're kind of to the end. So again, in each of these, whenever you have the name, just want to work backwards and kind of wait for the hydrogens for the very end. So working backwards here, I see pentane, which means the first thing I want to do really is lay up basically 5 carbons here. That takes care of the pentane. Trimethyl means basically I have 3 methyl groups hanging out, and their locations is carbon 2, 2, and 4. Again, because you are drawing it, you could go left to right or right to left. I'm going to go left to right like before. So I'm going to call that carbon 1, carbon 2, and so forth. That means I would go 1, 2, 3, and 4, if I counted right. There would be a methyl group there. And at carbon number 2, which would obviously be right here, there is not just 1 methyl group, but 2. That is my 1, 2, 3 for my trimethyl. That is done. Now we're just going to insert our hydrogens here. Guy on the far right here has one line coming in, needs 3 hydrogens to get the 4. Carbon next to it has 1, 2, 3 lines coming in, needs 1 more to get to 4. Guy next to it has 2 lines coming in, needs 2 hydrogens to get to 4. Carbon number 2 here actually has 4 lines coming to it, which means it's good, no hydrogens. And carbon number 1 there will need 3 hydrogens basically coming in. Any questions on that particular one there? All right, lastly here, kind of doing the same thing. We're going to start backwards. So I see butane, which obviously means I want to start with 4 carbons. Takes care of that. We have a chloral group at carbon 3 and a bromo group at carbon 2. I'm going to go left to right. So on my left-hand side, that is carbon 1. Next to it would be carbon 2, where I should put a Br. And next to that, at carbon 3, I should put a Cl. That takes care of everything there. Now we're going to fill in our hydrogens. Guy on the right there has 1 bond, needs 3. Guy to the left of him has 1, 2, 3 bonds, only needs 1 hydrogen. The guy with the bromine here, 1, 2, 3, needs 1 hydrogen. And carbon number 1 over here on the far left will need 3. Any questions on that? So really, I think the easier way, kind of going from name back to formula, because it's all there, always just work backwards and you should be in good shape. Any questions on anything we talked about here today?